Hey everyone, welcome into this video lecture on the integration by parts formula. We are going to derive the formula in this lecture by first remembering, number one, that we don't yet have a formula to compute the integral or antiderivative of a product of two functions. And number two, we're going to start this by remembering that we do know how to take the derivative of a product of two functions. So we'll start with the product rule for derivatives, which says that the derivative of a product of functions, f of x times g of x, is equal to the derivative of the first function, so d by dx of f of x, times the second function left alone, plus leave the first function alone, times the derivative of the second function, but I'm going to use the same notation here, d by dx of g of x. And what we'd like to do now is apply our knowledge of the fundamental theorem of calculus and integrate this entire equation. So we want to integrate this whole thing with respect to x, so I'm writing it like this. But really what I'm going to do is I'm going to integrate each piece of this individually, right? Because integrals are linear, and we can think of linearity as extending over an equal sign. And so what we end up with then is the integral of the derivative d by dx f of x times g of x dx right here equals the integral on this side. I'm going to change the order of these two just because we've got this derivative here. So this is going to be g of x times the derivative of f of x dx plus, this one's in a good order as far as the integral is concerned. This one is now the integral of f of x times the derivative with respect to x of g of x dx. And at this point we are going to notice that we've got some differentials, right? So this entire thing is just the differential of the product, okay? So this entire integral here can be written as the integral of d of f of x g of x. All right, and so in this notation, the integral cancels the differential. We're just going to be left with that product there. That's what we expect, right? If you take a derivative and then you undo it by an integral, fundamental theorem says that that's what you should get. So there's our differential notation here, but that's what we've got. The next two, we have differentials as well, but they're slightly different. So here we have a function and a differential, right? So this one says that this is the integral of g of x times df of x. This pink part right here is df of x. So the differential of f with respect to x. All right, the of x is usually not written. That could just be written as df, but it's just a reminder that everything here is in terms of x. And then finally, same thing over here, right? It's the same, but it's the opposite order, right? So we've got the function f and the differential of g, dg. So this is then the integral of f of x dg of x, and once again I forgot to color code it. All right, and what we can do now is notice in particular on this left hand side, this integral cancels, right? So what we have now is this formula, f of x times g of x is equal to the sum of these two integrals, right? So the sum of integral from g of x with respect to df of x plus the integral of f of x with respect to dg of x, right, as a function of x. And then we can solve for one of these to get our integration by parts formula. So I'm going to solve for this one. That's going to require me to subtract this one over, right? And when I solve for this, I'm going to rearrange it, get it on the left-hand side. So this one's going to say the integral of f of x times the derivative, I'm going to rewrite this out, okay? So derivative of g with respect to x dx, dg dx dx, that right there is dg. So if you're wondering what this is, right? This dg is exactly this. We know what this is. You might not have seen it written the way I've written it here. This is equal to then the product of the functions, so f of x times g of x minus this integral. So this is minus the integral of g of x, and then again our df here, df of x the way I've written it here, that by chain rule becomes, right, df dx times dx, and that's exactly the differential of f, right, with respect to x. So this becomes our integration by parts formula. This is it right here, okay? So this is our integration by parts formula. And we are going to take a minute to rewrite this in a way that maybe is a little bit nicer to look like, but we have to remember where this came from. So integration by parts. All right, so let's first take a look at what's happening here. This formula is going to be used to compute the integral of a function times a differential, okay? So it is like a product rule, except that one of the functions that goes in, so we started with the product rule for derivatives, right? And so, but what we end up with is a formula for an integral for which one of the functions is a function, a regular function. The other one, though, is a differential, so it's the derivative of some other function. And then how does integration by parts work? Well, it's going to take, the integration by parts method here is going to take this derivative and do a couple things. Number one, it's going to get rid of it. So there's just f of x times g of x. The derivative's going on that one. And then it's going to move it. It's going to move it over to the other function, right? And the derivative is over here on f now. So g of x times the derivative of f of x. But as it happens, we introduce a minus sign here. All right, so there's just kind of a heuristic idea of how this is going to work. Let's write out another formula here. So if we let u equal f of x, then du is equal to df dx by dx, right? Just the differential. And we're going to replace these in the formula. So we see we have df dx right here. So we have a u and a du. Same thing. If we let v equal our g of x, then dv, kind of in just simplified notation, right, is dg dx dx. So just the differential of g. And then our integration by parts formula is going to become the integral of f. Oh, sorry, let's get these new letters in there. Integral of u dv, right, equals u times v minus the integral of v du. All right, and so the integration by parts formula will become, after this change of variables, the integral of u dv minus, equals, sorry, u times v minus the integral of v du. So it moves the differential from one to the other, right, and it results in this formula. So this is easy to remember, but you have to remember where it comes from. It comes from a careful application of the product rule for derivatives, and this gives us our integration by parts formula. In the next few videos, we'll explore some applications of this, some actual computations, ways to use it, and an algorithm for computing this. So stay tuned.